So here are the main points from this lesson. First one, many real-world situations can be modeled using exponential relation. I know the ones that we did today were not very real, but things like population growth or population decay or money investing, so just like investing on GICs, a lot of stuff actually works out this way to have this kind of exponential function. Point number two, to check whether a relation is actually exponential, this is what we do. We check if the first differences, so first we check the first differences, and then it checks to have the same ratio. What is a ratio? It's something divided by something. So we check the value divided by the number, the previous first difference, and if that's always the same, we have the same ratio, then it's exponential. Let's check it on the example that we just did. Let me increase here. So the first difference is going from 80 to 40, I go down by 40. So that's minus 40. Going from 40 to 20, I go down by 20. And very interestingly, the first differences look exactly the same as the y's. But that's not always the case. So I gotta check the first differences and then the ratio on the first differences. So this would be minus 20 divided by minus 40, and that's positive 0.5. The next one is minus 10 divided by minus 20, and that's also 0.5. And next one is minus 5 divided by minus 10, that's also positive 0.5, and etc, etc. You get the point. Negative 2.5 divided by minus 5, 0.5, and negative 1.25 divided by negative 2.5 is also 0.5, because the ratios were all the same. We know that this relationship is actually an exponential function. 3, you can retrieve data from this textbook and paste it into a software applications like spreadsheets or Fathom for graphic analysis. So yes, you can actually go to some of the Canadian census and gather data for populations and income, etc., and actually do models on exponential function. And we're not going to do that in this course, but that's available. Last one, graphs of exponential functions can be decaying. Those are kind of coming down. They come down steep and then they average out. And they're always decreasing from left to right. It's not like a parabola that all of a sudden goes up or down. It's always decreasing. And it drives me crazy because it goes down forever but never reaches a certain number. We'll talk about that next class. Or exponential growth, the ones that are growing, that are always increasing from left to right. So if we look at our graph, this one's clearly decreasing, so therefore this is exponential decay. And the one that we did for the 1 penny to penny is clearly always going up, so this is exponential growth. So here are the 4 points for this lesson. Please take this down.